Okay, so you might remember that we were investigating y equals x squared as a parent graph. We called that a parent graph. And the reason we called it a parent graph was because we were using it and we were playing around with it. And we realized that a lot of things about that equation can happen to make that graph look different, but it still looks like a parabola. So today we're going to be investigating different functions, not just y equals x squared. We're going to investigate a whole bunch of different kinds of functions in problem 459. So if you turn to your books and you look at page problem 459, which is on page, I believe, 182, the substitute teacher can pause right now so that you guys can read what your task is for the day, and then we're going to just go over an example of what that means. When you're done, just hit play. So let's take a look at how we investigated the parent graph of y equals x squared. So first of all, we talked about what we did to that equation that made the graph shift to the left. So you might remember, and if you take a look at these equations that I have over to the left on your screen, shifting to the left, oddly, happened when we added something to that x before we squared it. So for example, I have y equals x plus 5 squared, and that shifted my parabola here over to the left. So what we did to shift it to the left was we added to the x y equals x plus something squared. Then we thought about, well, how can we shift it to the right? Like, what if I want to take that parabola and shift it to the right? So again, if you look over here at these equations, what we realized was if we took and subtracted something, what happened was that parabola shifted to the right. So if we wanted to answer that question, we would say we subtracted from the x, like y equals x minus something squared. So before we squared it, we subtracted a value from it. Okay, now how about shifting up and down? First of all, let's get rid of these so they're not in our way anymore. Now to move it up and down, does anybody remember what we did? Let's take a look. What's going to happen with this y equals x squared plus 3? You might remember, kind of stands to reason that this graph, same exact parabola, and it just moved up 3. So that we actually added to the x squared term. So to shift it up, we added to the x squared. But what did we do to shift it down? Well, that kind of stands to reason. We subtracted. So all of those things are how we, so let's say we shifted up by adding, and we subtracted to shift down. All right, and then just to show that shift down, we will shift it down 4 here. And now it went down 4. Same parabola, it just moved down 4. Now, do you remember what we did to squish or stretch the graph? Which part of what we did over here on the left did that? Can you remember? Let's see. I think it had to do with the number before the x squared term. So we multiplied it by some and then we, depending on what we multiplied it by, it opened or closed. We use this little, let's put that back. We use this little applet to show that. So when A changed, when A got smaller, the parabola bowl got bigger, and when A got bigger, the parabola got closer to the y-axis. So what kind of equation flipped it? Do you remember what value of A flipped it? If we look at this, if we change the value of A to a negative, it got flipped over. So this is how I would answer those questions. And then how do we generalize our equation? We put y equals x minus some value squared plus some value. So that's how we generalize that. Let's just move down here. And we called this h and this k parameters. And so those were the values that changed so that we can change our parabola. Oh, and we also had, of course, value in front there. And then we talked about all the different ways. So we said that, you know, HK is the vertex. We said that A shrinks or stretches it, and so on. So now you're going to go ahead and do that same thing. The substitute teacher will be handing out a worksheet right now for you to take a look at. And each one of you is going to get one. Each person on your team is going to get one different thing to investigate in that same way. So you're just going to kind of play around with it by adding numbers, subtracting numbers, and see what happens. And you're going to come up with as much as you possibly can for each of those sheets. Please help each other investigate and make sure that everybody on your team knows all 4 of those before you leave. So you're going to investigate each one of those and write your answers on the sheet. And I'll be taking a look at those before next class. So make sure your name is on them. And then for homework, for Wednesday, you know you have your individual tests. So I want you to work on checkpoints 4 and 5 and these problems that I listed on the Moodle site, and they're listed again here. And then for Friday, your homework is these 4 problems, so you can spend the remainder of class studying for the individual test that is coming up on Wednesday and working on homework for Friday. I'll see you Wednesday.